Hi guys, Viva here from Bright Young Brains. So we've been working on differentiation, right? And today we're gonna work on equation, or rather getting the equation. That's better. The equation of a tangent to a curve. That's what we're gonna work on. Before we dive into that though, we need to quickly sort out cases like this. So we have already worked on simple ways to differentiate. However, we know that differentiation, as simple as it may be, your initial expression will usually be chunky. So when you're given stuff like this, especially in grade 12, we need to keep in mind that if you need to differentiate this, we will not be able to differentiate it immediately. Keep in mind that I am referring to if you're in grade 12. If you're in grade 12, you cannot differentiate this immediately. If you're not in grade 12, obviously, maybe first year varsity or AS Maths, this you can differentiate immediately using the product rule. However, within the scope of this tutorial, we're not going to work on that. We are mainly working on the simpler grade 12 ways of doing things. So I think as long as you can keep in mind how slightly simpler the work is, I hope that kind of gives you the strength, or it motivates you to at least, not be too beat up when it seems a bit hard. I think it's just a mind game. So just try and keep in mind that whatever you're going to be working on, if it seems difficult, maybe just leave it for a bit and then just go back to it. But then don't put yourself in a scenario where you think it's hard because it's really not. So just keep that in mind, right? Anyways, if we have to differentiate f of x, we cannot differentiate immediately. We have to simplify. Now, us simplifying, it means that 2 to the power of x, 2x to the power of 3. This, for now, just stays the way it is. However, can you see here we have x minus 2 in a bracket, the whole thing squared. Now, this we have to expand first. So we've expanded. If you want, you can FOIL up the two brackets first and then multiply the 2x to the power of 3. However, to just show different methods that are mathematically correct, what we could easily do here is we could firstly multiply the 2 to the power of 3x into this one bracket, and then whatever we have, we multiply that into our other bracket. So what that will look like is this. For now, we have just multiplied the 2x to the power of 3 inside, and then we've multiplied the 2x to the power of 3 with negative 2 as well. So we know that this multiplied by that first bracket, this is what we have. Our second bracket is still just there. Here now we can multiply using normal foiling method. The first one with the first one, etc. Like that. And then we know these two in the middle are just giving us negative 8x to the power 4. So at the top, this is what we're given. They want us to differentiate. We cannot differentiate immediately, so we have to simplify by expanding and then foiling out. This is what we now have. This is still just f of x. It is not differentiated. However, now we can differentiate. There we go. F of x differentiated will just be 5 times 2, 10. 5 times 2 is 10. And then 5 minus 1 is a 4. And then we just repeated our differentiation method for each term individually. So we know that at the top, in grade 12, we cannot differentiate this the way it is. However, if you're not in grade 12, you will be able to use the product rule. And then while using the product rule, you'll need to use the chain rule. So it's a whole nother story. But then for the scope of this tutorial, like we said, we're trying to keep things as simple as possible. So now we can easily work on the equation of a tangent to a curve. So the main reason why we went through that example is to give us the idea that with a lot of the questions that you're going to be getting on differentiation, they are all heavily hinged on firstly you understanding the question, like what it's asking for, and also being able to juggle a lot, as in being very comfortable with normal algebra. Anyways, so with an equation of a tangent to a curve, this is one key thing. If we have here a normal parabola, this parabola is not symmetrical at the y-axis. It's just the random parabola. Let's just keep that in mind. So with this random parabola, if I have a certain point where a tangent passes through that point, I will always need to keep in mind that at this specific point, right, two things about our tangent and our curve will be equal. Firstly, at this very point, we know that for our curve and our tangent, firstly, at this point, two things will be equal, right? The first one is the coordinates at that point will be equal. The second one is that the gradient at that point will be equal. So before we can understand the equation of a tangent to a curve, one big thing we always want to remember is that where a tangent meets a curve, two things will be equal at that point. The first thing is at that point, the coordinates will be equal. The next thing is at this point, the gradient of the curve at that specific point will be the gradient of the tangent at that point as well. So I'm mainly emphasizing on this specific point because keep in mind that this is a curve, right? So meaning the gradient at different points on this curve will not be the same, as in the gradient here and the gradient there, it's different, you see, because a curve, the gradient differs throughout. However, the gradient at this particular point is the gradient of our entire tangent, because a tangent is just a straight line and all straight lines have one single gradient. So to make better sense of what has just been said now, a curve at different points has different gradients. A tangent at different points has the same gradient. So at this particular point, if we know the gradient of the tangent, we will automatically know the gradient of the curve. If we know the gradient of the curve at that particular point, we will automatically know the gradient of the tangent. Vice versa with coordinates. If we're given the coordinate there, we just need to keep in mind it's the same coordinate for our tangent and it's the same coordinate for our curve. So this is very important for us to be able to understand how to get an equation of a tangent to a curve. So this scenario, the way it's been laid out, we need to keep in mind one key thing, right? And that is, if we're ever going to be asked to get the equation of a curve, so we have here a classic equation of a tangent question for cubic functions or for functions in general. We have here f of x being our curve. The equation of f of x is x minus 2 closed brackets squared minus 1. So it's clearly a parabola. It's clearly a parabola that has been moved 2 places to the right and then 1 place down. That's the format we have here. That's the equation of our curve. Our tangent is clearly a straight line, obviously, because remember, all tangents are straight lines. That's blunt, but keep that in mind. We know that this equation of our tangent, we are not given anything, so we know that they will usually just give it to you in the form mx plus c, right? We have a curve, we have a tangent. This is our question. Find the equation of g of x if g of x is a tangent to f of x, where x is equal to 3. So this question may seem a bit chunky. Main reason is we have an equation, we have a picture, we have another equation, and we have a question. So it seems as though a lot is just flying around. However, this is like a classic question. It's common. You will always have to know how to answer questions like this.